So introduction to geometry proofs, and then 2.6 will be geometry proofs today. But we basically did everything last class period that you needed for 2.5 except practice some more examples together. So that's what we're going to do this morning. You probably won't have very many word problem type examples, but I do want to go ahead and do one like this. It's not very difficult, just in case you do have one or two. Most of your proofs are going to be pretty straightforward, like solve this equation, justify each step. And when we take the Chapter 2 test, it will not be all proofs, okay? It will be over all the things, just like the quiz you just took. We'll go back and look at patterns. You'll have to predict the next item. You'll have to write if-then statements. You'll have to write converse, inverse, conditional, contrapositive, all of those things, okay? So it's going to have a few proofs on it, but it's not all proofs. So if proofs are scaring you, or if they do after today, don't stress because the test will not be over all of them. Won't be all proofs at all. And we'll talk more about the test and how many of everything's on it when we get closer to the test. All right, so what did we say? Every proof we're going to do in here is going to look like a T-chart table. Two-column proof is what it's called. So we're going to start this problem by making a two-column proof. What are we always labeling on the left? Statements. Good. What's going on the right? Reasons. So every single problem on your homework that says write a justification for each step, you are writing it like this: two columns, statements, reasons. Okay? Then remember that you have to number your statements and your reasons. And those are little picky details, but they are free, easy give me points as long as you set it up correctly. If you don't, then you're going to miss those things. So I don't want to take off points. I want you to get it set up correctly. Okay, so when you have a word problem, you're going to be picking out what's important and what's the given that you need to list from that word problem. So it says, what is the temperature in degrees Fahrenheit when it's 15 degrees Celsius? Solve the equation for F and justify each step. So when you read through that, what's one thing you think we definitely need to write down as our given? Bailey? Okay, 15. So what is 15 standing for? C, right? Celsius. So that means we could write C equals 15 degrees because they're telling us what the C value is. And that is given. What else might be important up there that we need to write down? The equation, right? We need to solve that equation for F. So we need to list that. You can write it as a separate step, or since it's all given, you can list it in the same step. That way you don't have to write given twice. Okay, and then do we have enough information at this point to solve for F? Yes, so what would we need to do? Plug in 15, exactly. We need to plug the 15 in for C. What do we call it? What property do we use when we're plugging something in? I heard somebody say it. Substitution. Thank you, Michelle. Substitution. Substitution is what it's called when you're plugging it in. So I'm going to go ahead and list my reasons since that's what I'm thinking I'm going to do. And so it's substitution what? Property, good, of equality. Good. Substitution property of equality is what we're going to use. And then we're going to substitute that in. Be careful that you don't do more than one step at a time. When you substitute it in, you're just replacing the C with the number 15. So F equals 9/5 times 15 plus 32. Just substituting it in. So now what do we need to do to solve for F? Okay. We need to multiply 15 and 9/5. Now be careful. So I heard two different things there, distribute and multiply. What property are we actually using when we do 9/5 times 15? It's not multiplication. Multiplication, addition, subtraction, and division properties are only if you are doing it to both sides of the equation. Look back at your property sheet and make sure that you wrote on there both sides of the equation. Did you guys write that by the first four properties? Okay, I stressed that last class. Sydney? You are combining what? Like terms. That's exactly what we're doing. But I want to make sure everybody's clear because one of the most common mistakes is students think, oh, I'm multiplying. That's multiplication property. It is not multiplication property unless you are doing it to both sides of the equation. And that goes for addition, subtraction, and division. Okay? If you are just multiplying on one side of the equation, that is simplify or combine like terms. Either one. It's not distributive property either. Remember that just because you have a parenthesis doesn't make it distributive property. Distributive property says you have to have two terms inside your parentheses and a term out here. And you are distributing that to more than one item. Okay? And we're not distributing it. We're just simply simplifying what 9/5 times 15 is. So what is 9/5 of 15? Any ideas? Got a calculator, type it in if you're not sure. 27, good. So we have 27 plus 32, and we used the combine like terms or simplify. I'm going to just put simplify because it's quicker. But you can write either one, combine like terms or simplify. And this is number 3. Okay, what would we need to do next? Okay, we need to add. Is it the addition property? Are we doing it to both sides? No, it is not the addition property unless you are doing it to both sides of the equation. So what do we call it if we're just adding two terms on one side? Combine like terms or simplify, either one. So we're going to simplify again. And what are we going to get for our final answer for F? 59. And what are our units here? Degrees. We're talking about the temperature in Fahrenheit. So make sure you do include your units even in your proofs, okay? Questions? All right, let's practice a little bit more. This is going to be our basic introduction to geometry proofs right here. So before we look at it, I want you to look at this slide. Put this in your notes to remind you of a notation skill from chapter 1 that I continue to see people making mistakes with. What does it mean when you have two capital letters side by side? Nothing's above it. It means distance. Good, Jackson. It means distance. Distances are equal. So when you're using an equal sign, you're talking about a number value. You do not put a line segment above AB. If it's two capital letters side by side, that means distance, and you're going to use an equal sign, and you're talking about numbers. What does it mean when you have two capital letters with a segment written above it? It's a line segment. Shapes, like line segments, are congruent. So you're going to use a congruent symbol, and you're talking about that segment is the same as another segment. So anytime you're putting a line above it, you should not be using an equal sign. You should be talking about the segment being congruent to another shape. If you're talking about a number or distance, do not put a line above it. You're using the equal symbol. Does that make sense? Questions? Okay, super important for when we go to the next part with our proofs. Okay, we did problems like this one and the next one back in chapter 1, and this is a great review for those of you who struggled with the chapter 1 test or had problems with these kinds of questions on the chapter 1 test. So first of all, it says write a justification for each step. Does it give us an equation that we need to solve? No, we're going to have to come up with the equation, and there is a property or a postulate or a theorem that we learned in chapter 1 that allows us to come up with an equation. What postulate, property, or theorem did we learn in chapter 1 that lets us come up with an equation? Good, Bailey. Part plus part equals whole. But you need to know what the name of that is. What is that postulate, property, or theorem? What's it called? Okay, here's where students struggle with proofs. You cannot do a proof if you do not know the names of your postulates and theorems. You will not be able to do them. You will never get better at them unless you have studied those theorems and postulates. So what I want you to do right now is everybody get out your textbook. Get out your book. Jackson, get out your book. You didn't bring your book. You have to bring it every day. Haley? No, we're not getting together. Where's your book? Neither one of you. Guys, this is not optional. You have to have your textbooks. Anybody else not bring their book? Landria, who else? Okay, I'm going to start writing lunch detentions for not bringing your supplies to class. You have to bring your book. Not optional, okay? Have to bring it. Okay, look in your textbooks right now. Those of you who don't have one, you're just going to miss out on this part, but pay close attention. Open your textbooks up to the back of your book where there is like a sea green, bluish, teal, whatever color you want to call it. Perfect. I'm going to borrow Carlos's and show you since he's got his turned there. So you're looking for this color right here. So find this section in the back of your book. Should be right after the orange selected answers or whatever that is. Orange problem solving handbook. Okay, this is where you can find by chapter the postulates and theorems that you need for each chapter. So we're in chapter 2, which means you could be using a postulate or a theorem from chapter 1 or from chapter 2. So when you're at home working on your proofs and you're like, man, I have no idea what to do, it could be that you just don't know the postulates or theorems. So open your book up, go back here, read through them until you can find one that you're like, oh, that's what I need to use. Okay? So this is going to be a great resource. And every chapter we're going to learn more and more. And so this is a great resource to go back and use. Exactly. So Bailey knew the big idea. Part plus part equals whole is what we need to use, which was all we really needed for chapter 1. But now in chapter 2, we actually need to know the name. Segment addition postulate. So we're going to start there. It does say write a justification for each step. So go ahead on your notes and make yourself a T-chart. Statements, reasons, but then statement number 1, this time, we're not going to start with our given. We could. It would be totally fine if you started with the given, and the given's what's in the picture. But what we first thought was, we need to write an equation, and we need to use part plus part equals whole. So our reason here is going to be what Chris said. Your reasons are going to be your definitions, your theorems, your postulates, your properties. And he said segment, addition, postulate. And so until you get that memorized, looking in the back of your book will help you find and figure it out, because you'll see it and you'll think, oh yeah, that's where it says part plus part equals whole. Okay, but this next statement part that we have to write down is not the equation with the x's and the numbers. If you look at where it says segment addition postulate, they don't tell you an expression plus an expression equals an expression. They tell you the names of the line added together equal the whole line. So what are our names of our parts in our picture? Okay, not the actual algebraic expressions. We're not starting with that. If you look in your book, that is not what it says under segment addition postulate. What does it say? Very good, Reese. It uses the names of those distances. So we're going to say NM plus MO equals NO. Naming the parts. But do we put line segments above them? Never, ever, ever when you're using an equal sign, because what you're talking about is the number distance plus the number distance equals the total distance. Okay, so no line segments. All right, the next thing we need to do is list our given. The given is coming from the picture. And again, these could have been in the opposite order. You could have listed your given first and then your segment addition postulate. So let's list what was given to us. What do we know in the picture? 2x. So what is 2x equal to? NM. So we're going to say NM is equal to 2x. That's what they gave us in the picture. They didn't give us an equation. They just gave us that information. What else? Very good. MO is equal to 3x minus 9. What else? Good. NO is 4x minus 4. So you're just going to look at your picture and pick out anything that was given to you in the picture. And now what would we need to do to try to write this actual algebraic equation? Plug it in. We need to plug in our NM, plug in the for MO, and plug it in for NO. So what do we call it again when we plug something in? What property is that when you plug it in? Say it again. It's not combining like terms. That's when you're just doing something to one side of an equation. We're trying to substitute things in for parts of the equation. Substitution. Anytime you're plugging something in, that is substitution because you're substituting it in. So substitution what? Property of equality. All right, I'm going to go ahead and write my reason so I don't forget what it is I'm doing. And then I'm going to substitute those things in. So what is our equation actually going to say? Perfect, Chris. And this is where you started in chapter 1. When I gave you a problem like this on the test, you started with step number 3. We didn't list out every single step by step, but a proof is a step-by-step process, okay? So make sure that you are listing step by step by step. All right, from here, we just now have an algebraic equation that we need to keep going and solve. So the only thing that was different here was using our geometry postulates and our given. Everything else here is going to be just what we've been doing. So I'm going to go ahead and go over here to the board where I've got a little bit more room, and let's finish this. So number 4, what's the first thing we want to do to solve that equation? Good, combine like terms. So that means my reason is combine like terms or simplify. All right, combine like terms this time. And what am I combining over here? 2x and 3x. So what is my next statement going to be? Okay, so 5x minus 9 equals 4x minus 4. 2x plus 3x is 5x. Okay, from here, there's a lot of options of what you could do. Just depends on how you want to solve the equation. So you and your partner may not have the same answer. What do you want to do? Okay, Chris said subtract 4x. So I'm going to subtract 4x. Remember that you do not show your work in your proof. If you need to show work, go over to the side, rewrite the equation, and show your work over here. What you're writing in your equation is the result after you subtract 4x. So what do I get when I subtract 4x on the left? X minus 9 equals negative 4. Be really careful with your signs. So we're going to put x minus 9 equals negative 4. And what did we do to get that? Subtraction property of equality. Okay, so what do you want to do next? Add 9. So I'm going to go ahead and write down what I'm doing. If I'm adding 9, what's my property? Okay, and again, it's because we're doing it to both sides, right? We're adding 9 to both sides. Addition property of equality. So if I add 9 to both sides, what does that make my answer for number 6? X equals 5. Good. Is my variable on the left? Yes. Remember, you're not done until your variable is on the left and by itself. If it was not on the left, what property do we learn last class period that flips it over? Jacob. Close simplify is only if you're taking one side and you're trying to combine the like terms. It doesn't flip it, but it does start with an S. Symmetric property. Symmetric property takes an equation and flips it over. So if the x had been on the right, we could have flipped it using symmetric property. Questions? Okay, let's try the last one in our notes. It's going to be very similar to what we just did. So in chapter 1, you worked problems just like this also. Again, when you look at the picture and look at the problem, are they giving us an equation? They don't give us an equation, right? There's no equal sign anywhere on the board telling us as far as an entire equation to solve. They do tell us down here that ABC is equal to 8x, but it doesn't give us an equation to solve. So what am I going to have to use to come up with an equation? Exactly. This is exactly what we just did on the last problem, except our picture is not a line segment. What's our picture about? Angles. But we still need to do part plus part equals the whole, and that is the angle addition postulate. So it's the exact same thing, but now our picture is just about angles. So again, write a justification for each step means draw yourself a T-chart, statements, reasons. First thing we're going to list is the equation that comes from the picture using the angle addition postulate. All right, again, the angle addition postulate does not say variable expression, variable expression, variable expression. It goes back to naming the parts of the picture. So what is one part in the picture? Okay, so that's our given. That's something we'll list in a minute. But right now we're trying to write the angle addition postulate that says part plus part equals whole using the names of the angles. Good. And the only thing I'm going to add to what you said, Chris, was measure on each of the parts as well. So when he named them, he started with angle ABD, so the first part. But remember, when you're talking about a number, what do you always put in front of the angle? Measure, the little m, right? So measure of angle ABD plus measure of angle. The second part was DBC. And that should equal the measure of angle. And the whole thing was ABC. Oops. That was not good. Let's go back. So measure of angle ABC. Any questions there? Watch your notation. Pay close attention to the details. Little m's when you're talking measures, anytime you're using the equal sign. Okay, number 2. What are we going to need to list in our proof before we can come up with the equation? The given, just like on the last one. These are identical kinds of problems. It's just one's about angles, one's about segments. So what is given to us in the picture? Okay, measure of angle, ABD, equals 3x plus 5. What other angle measure do we know? DBC, good. Measure of angle DBC is equal to 6x minus 16. And what's the other angle measure they give us? ABC. So measure of angle ABC is equal to 8x. So all we did was list what the picture told us and then wrote down what geometry, theorem, or postulate in this case do we know that lets us write an equation. And now what are we going to do to get that equation? What are we doing? Substitution. We're just going to substitute it in just like the last one. So we're going to use the substitution property of equality. Substitution property of equality, and we're going to write our equation. So we'll plug the 3x plus 5 in and get 3x plus 5 plus, plug the 6x minus 16 in, equals, and then plug the 8x in. And now we have our equation. Okay, let's go through and solve that equation again just to practice these properties because I don't feel like we're still really confident on some of them. All right, so let's go with Barrett. What do you want to do first here? For step 4. Okay, so we can combine like terms. So I'm going to put on number 4, combine like terms. And you said combine the x's. So on the left-hand side of the equation, we have a 6x and a 3x. What is 6x plus 3x? 9x. Okay, I am going to say, if you would like, you can also combine the other like terms at the same time because they don't depend on each other. Or you can do them in separate steps, and that's totally fine too. So I could add the 3x and 6x, and at the same time, I could add the 5 and the negative 16. And the reason I can do that all at once, again, is because the result of adding the x's does not affect the result of adding the other numbers. Does that make sense? So what is positive 5 minus 16? Negative 11. And that equals 8x. Okay? Brian, what do you want to do next? I'm sorry, say it again. Like, what would we need to do to solve this for x? Any ideas? Nope. Help him out, Jackson. And what are you adding? Okay, and what are you subtracting? Okay, so you want to subtract the 9x to this side, right? Brian, does that make sense that this is a positive 9x and we want to get our x's on the same side of the equation? The opposite of adding 9x is subtracting 9x. So we're going to subtract 9x from both sides. If we do that, then we're using the subtraction property of equality. Okay, again, don't show your work in your proof. So if you need to show work, take 9x minus 11 equals 8x. And over to the side, write minus 9x minus 9x. What is that going to give us for number 5? Negative 11 equals what? Negative x. And you can put a 1, but it's not necessary, right? Either way. Are we done? No, what do we need to do next? Michelle? We could use the symmetric property next and flip it over. We're going to have to flip it at some point. Doesn't matter if we do it now or do it later. So I can go ahead and do symmetric property. So this would be negative x equals negative 11. Flipping it over to get the x on the left. If I do that again, it is symmetric. And by the way, symmetric is 2 m's. Symmetric property of equality. What would I need to do, though, next? Haley, what do you want to do to finish solving for x? Good. And what are we dividing by? Negative 1. Could I have used a different property other than division property? I could have done multiplication property. What would I be multiplying by? Negative 1. And either one would give me the correct answer. So you're going to have, for your answer, x equals positive 11. But your reason could be division or multiplication, and both answers would be correct. I'll do division since that's what Haley said. Division property of equality. Questions? Is this making sense? Feeling good about it? Any questions? Okay, we're going to jump into a few real geometry proofs. But you should have enough information now to finish the assignment you got on Wednesday. Okay. So let's look at 2, 6. Same process. If you're doing a proof, you are writing it as 2 columns. You are doing statements and reasons. You are numbering them 1, 2, 3, 4. Okay? We set up our algebraic proofs that way so that it would make the geometric proofs that much easier. Maybe. Here we go. So the first thing you should see in your notes is this chart, right? And all this basically says is when you write a proof, you are going to be given some information, which is your hypothesis, and they're going to tell you to prove something, which is the conclusion. And the way you're going to get from the given to the prove is you're going to use your definitions, your theorems, your postulates, your properties that we have learned to back up every single statement. These are going to be different than your algebraic proofs in that it's not a step-by-step process that you've learned over and over again. Makes it a little harder because you have to know what the postulate says or what the definition says. So again, I'll give you an example. If I tell you that M is the midpoint of line segment AB, what does it mean by the definition of midpoint that I now know if M is the midpoint of line segment AB? Back to chapter 1, what did it mean if M was the midpoint? That what's congruent? Points can't be congruent. What in your picture? Exactly, Sydney. So AM and BM, these two distances, their line segments are now congruent. The definition for midpoint said splits into 2 congruent parts. And that's where it's going to be hard. You have to know, what does the definition say? What does midpoint mean? It means that AM with a line segment above it is now congruent to BM with a line segment above it. Okay, that's the definition. Splits into 2 congruent parts. So when you're doing your proofs, if they say M is the midpoint, then you can say, okay, the next thing I can say is AM is congruent to BM. Okay, that's the thought process we have to get to do well on the proofs. They're going to start off easier in that they're going to make them fill in the blank. So they're going to set it up for you, and all you're going to have to do is try to come up with what's the reason on this first example. If you'll notice, you have statements listed, right, on your paper. 1 through what? 1 through what? 4? Okay, I can't show mine up here because it puts the answer up automatically on the PowerPoint. So I'm going to list them with you. Before we do that, though, what are we supposed to always start with? A T-chart. So on your paper, go ahead and make a T-chart. Even though they've listed all these statements, go ahead and surround that with a T-chart. And what do we label the left side? Statements. And what do we label the right side? Reasons. Make sure you're writing this down with me. This is probably one of the hardest things we're going to learn, and it's not going to go away the entire semester. We're going to build and build and build, so make sure you're with me right now. Okay, so what is the first statement on your paper? Somebody read that to me. Angle A and angle B are what, I'm sorry? Are supplementary, okay? What's statement 2? Okay. What is statement 3? I'm sorry, equals what? 180. And statement 4? I think we missed a statement there somewhere. Statement. Okay, so this is statement 1. So what was statement 2? Equals the measure of, or equals what, I'm sorry? 180. Okay, and then statement 3? And then the statement 4. right. So what your goal on this is to come up with what is the reason for every single step. The first thing you should always do is go back to the original part of the problem up here. Everybody with me? Look up here. Go back up to the very beginning and look for what it tells you the given is. And then find all of the given in your proof. Sometimes they'll separate the given. And given may be statement 1, it may be statement 5, it may be statement 8. And you'll put given for 1, 5, and 8. So make sure that all of your given is listed and you know where it is and that you've put the reason as given before you ever start your proof. Those should be easy, free points on a proof. So what is given up here according to the directions? Number 1, A and B are supplementary and angle A is 45 degrees. And that's all that's given, right? So given cannot go anywhere else. None of the other statements are given. We have to figure out how they knew that. What geometry, definition, theorem, postulate, or property did they use? So what tells us, number 2, that if A and B are supplementary, that means that they add to B 180. Careful angle addition postulate says if you have a picture of an angle that has been split into 2 angles, part plus part equals whole. We don't have an angle that's been split into 2 angles. Look at what they told you. When you're trying to decide the reason, you're not just trying to pull it from thin air or think about everything you've learned. You're looking at 2 places. You're looking at what did they give me? Did it come from something they told me here? Or you're looking at the picture and asking, did it come from the picture? So what did they previously tell us in number 1 that would let us know that A plus B is equal to 180? That is something they gave us, but it doesn't tell us that A plus B equals 180. What tells me A plus B equals 180? Okay, angle A and B are supplementary. So what's going to be my reason here? What definition, theorem, postulate, or property am I going to write down as my reason? Congruent supplement theorem is different. It says that if 2 angles are supplementary to the same angle, then those 2 angles are congruent. But we're not trying to say that 2 angles are congruent. We're just trying to say that they add to equal 180. Linear pair theorem says if you have a picture of a linear pair, but we don't have a linear pair. Linear pairs have to be adjacent and form a straight line. Okay, I'll give you a hint. It's not a theorem or a postulate. So what definition or property do we know that says A plus B has to be 180 according to what they just told us in number 1? Okay, exactly. Jackson said it a couple times up here. What did they tell us about A and B? They're supplementary. What does supplementary mean? It means 2 angles add to equal 180. So take what they just gave you and see what did that lead, what reason did that give me for this? So number 2 should be definition of supplementary. You cannot just write supplementary. You have to write definition of supplementary. We're not abbreviating. I said that, yes, last class. No abbreviations whatsoever. You're writing it out. We're preparing for the end of course test, and people from the state are going to be reading what you write, and if you get in a bad habit of abbreviating now, they will not know what in the world you're talking about. So we're going to write everything out to get prepared, okay? All right, number 3. Again, you're asking yourself, what did they give me up here that let me say number 3? So look at what you had in number 2. A plus B is 180. Look at the difference in number 3. What did they change in number 3? Okay, they said that instead of A, they have 45. What did they tell us up above that let them change A to 45? Okay, A is equal to 45. So what did they physically do? What theorem, definition, postulate, or property did they use to change 2 to 3? Substitution. Good. We're getting there. Substitution, property of equality. Substitution, property of equality. They just took this 45 degrees and plugged it in for that angle A. Okay, again, don't write on your proofs like I just did. I'm just trying to illustrate for you. All right, now look at what they did to get from 3 to 4. What did they do to change from 3 to 4? Very good, Chris. They said, all right, I got 45 on the left. I'm going to go ahead and solve for B. I'm going to subtract 45 from both sides. So they used the subtraction property of equality. And that is it. So you're trying to fill in the blanks based on their statements that they've listed. Okay, let's try another one. They'll be similar, not all, I mean, there's not a procedure for geometry proofs. It's not like solving an equation. Every time this is what you do. You have to look at what's given and try to work your way there. Right now, we're doing just fill in the blank, but before long, you're going to have to try to write an entire proof all by yourself. Given this, prove this, and you're going to try to do the whole thing. Okay? But we're working our way there, baby steps. Okay, so one more time, write a justification for each step given this information, and they wrote all of the statements for you. So go ahead and make your T-chart around it. Left side is statements. Right side is reasons. Go ahead and number your reasons 1, 2, 3, 4 to match your statements. What's the first thing we want to do? Find your given. I promise you, if you don't do that, you're going to be looking at a proof on the test, struggling with what is the reason for number 5, and you're going to be so frustrated that it was just given. You need to look and make sure that you have all of the given listed in your proof. So what's one thing at the top that they give you? B is the midpoint of AC, right? Does everybody see here where it says given? B is the midpoint of AC. So that means number 1 is given. These are easy freebie points. Don't make proofs harder than they are, okay? Is that all they give you? No, what else do they give you? AB is congruent to EF. Where is that in the statements? Number 3. So what's the reason for number 3? Given. Okay, so right there, if this proof was worth 4 points, you would already have 2 out of the 4. Just making sure you can find your given, okay? From here, remember you're doing 2 things. 1, you're going to look at what you had in number 1 and ask yourself, what did they tell me that would let me believe number 2? And if you can't figure it out, then you'll go to the picture and say, is it something from the picture? But start with what they've given you in number 1. You can't use things that are down here because you're trying to fill in number 2. But look at number 1. They say B is the midpoint of AC. So go to your picture. B is the midpoint of AC. What did Sydney help us just review a minute ago that we now know? Okay, good. I don't know if you can hear Chris, but he said if B is the midpoint, then segment AB and CB have to be congruent. Is that what they just said? And so what did they use to get that? The definition of midpoint. It's not going to be a word that's just out there somewhere in the space. It's going to be something they've just told you, okay? So definition of midpoint. Okay, now you've got to think a little harder because you are trying to figure out what's the reason for number 4, which means it could come from all 3 of these up above. So you've got to look at everything you have up above and ask yourself, what did they do to get from these statements to this statement? So let's go back through what we have. B is the midpoint, so now I know AB is congruent to BC, and they told me AB was congruent to EF. And now they're trying to say BC is congruent to EF. So they're trying to say this is congruent to this. And they were each congruent to AB. What did they use to do that? Exactly, Alex. Good. Just last class period we talked about if you have A is congruent to B and B is congruent to C, the parts they have in common that are identical can go away and you can combine the other 2 parts. That's your transitive property. Notice there's 3 equations that were used, 2 that were given and one that you came up with. So 3 equations, RST 1, 2, 3. Combining, if they're identical, and you get rid of those, that's transitive. And again, it's transitive property of, careful, what's the symbol in the statement? Congruence. Always make sure that your statement and your reason match in your symbols, okay? How are we feeling now? Kind of shaky a little, huh? Still trying to figure it out, but getting a little better. This is something that just takes time and practice, okay? A theorem, we've already learned theorems because back in chapter 1, I had you write down vertical angle theorem. It's probably the only theorem that we've learned, or I guess, we haven't talked about linear pair theorem, have we? Is that chapter 2? It's in chapter 2, so I think that's coming up today. So, vertical angle theorem you have learned before. That just says simply that vertical angles are congruent. So if you remember back in chapter 1, we said if we had vertical angles, those were congruent. But a theorem is any statement that you can prove. So every theorem that we learn in here, there is a mathematical proof that can be written in 2 columns to back up whatever we're saying. We're not going to prove every theorem that we learn, but there is a proof. Okay, so here is our linear pair theorem. This is the first time we've ever talked about it. We've talked about the idea of the linear pair theorem, but we've never said those words. Okay? So this is a new second theorem that you're learning for this course. Here's what the linear pair theorem says, and I love these charts because they're going to help you with your proofs, okay? So focus with me here. Notice this says hypothesis. That means that this could be one of your statements in your proof. So if in your proof somewhere it says angle A and angle B form a linear pair, okay, if it says that, 2 angles form a linear pair, then what you can conclude next, so your next statement could be angle A and angle B are supplementary. And the reason that you would put for that statement, reason 2, would be linear pair theorem. So if 2 angles form a linear pair, remember chapter 1, linear pair means 2 angles that form a straight line. If 2 angles form a straight line in your picture, then they're a linear pair. And if they're a linear pair, you can say they are supplementary. And if they are supplementary, that comes from this linear pair theorem. Okay, so we're going to have to use that. Super important. Okay, congruent supplements theorem. We haven't actually talked about that, but Michelle brought it up when she was looking at the back there in those chapter 2 proofs. This one's a little more complicated. I want to make sure you're with me, so I'm going to draw some pictures here to help make it make sense. Congruent supplements theorem says if 2 angles are supplementary to the same angle. I'm going to draw you a picture of what that could look like. Okay, what do we know about angles 1 and 2? Okay, they're supplementary because they form what? A linear pair. Okay, so angle 1 and angle 2 are supplementary. All right, what do I know about angles 2 and 3? They're supplementary because what do they form? A linear pair. So angle 2 and angle 3 are supplementary. So think about it with me. If angle 2 is, let's say, 50 degrees, what does angle 1 have to be so that they are supplementary? 130 degrees. Okay, what does angle 3 have to be if 2 and 3 are supplementary? 130 degrees. So what do we notice about angles 1 and 3 since they're supplementary to the same angle? They're congruent. They are vertical in the picture. Is that what you said, Bailey? But what we're trying to get at is what do we know because of the fact that they're supplementary to angle 2? Since these 2 angles are supplementary to the same angle, then those 2 angles, 1 and 3, are going to be congruent. That's what the congruent supplements theorem says. If two angles are supplementary to the same angle, then they have to be congruent. So again, how would that look in a proof? In a proof, you might have statement 1, angle 1 and 2 are supplementary. Maybe later you have statement 2 that says angles 2 and 3 are supplementary. And you recognize, oh, they're both supplementary to the same angle. So then you could say statement 3, 1 and 3 are congruent. And the reason for statement 3 would be congruent supplements theorem. Does that make sense? Okay, same exact idea. I want us to skip ahead to congruent complements theorem. So we're going to skip ahead to that so that you can see they're almost exactly the same thing, except one's about supplementary and one's about complementary. Okay, what does complementary mean? Add to be 90. Okay, so I'm going to skip ahead here. And I want you to look at this chart. Find that chart in your notes. Everybody with me? Okay, so I'm looking at this one right here, and we'll come back up to right angle congruence theorem in just a minute. We're almost done for today. So congruent complements theorem says the same exact thing. It says if two angles are complementary to the same angle, then those two angles are congruent. So a picture that you might see could be something like this. Okay, it's kind of hard to see those right angle boxes, but do you see that I put two different right angle boxes? A green one and then a black one? So do you notice that angles 1 and 2 form a right angle? So they are complementary, right? So angle 1 and angle 2 are complementary. Do you notice that 2 and 3 form a right angle? So 2 and 3 are complementary. So again, this could be statement 1 in your proof. This could be statement 2 in your proof. So that means that angles 1 and 3 are both complementary to the same angle 2. If they're complementary to the same angle, then that means those two angles have to be congruent. That would be your statement 3, and your reason for that statement would be congruent complements theorem. Is that really making sense? Again, let's throw some numbers in there. Let's say that angle 2 is 40 degrees. What does angle 1 have to be so that it forms a right angle? 50. Okay? Again, if we look at the blue right angle, if 2 is 40, what does angle 3 have to be? 50. So we've got 2 and 3 forming a right angle of 90. We've got 1 and 2 forming a right angle of 90. And since 2 is in common with both of them, 1 and 3 then have to be the same measure. Okay? All right. I'm going to look at Carlos's here and see if there's anything else I want to point out before we stop for today. And try. Let's go back and do just the flip back over. We're going to do one more thing and then we're going to stop because I know you're tired. This is your definition for two-column proof. Okay, this is your definition. We started our two-column proofs yesterday because I knew it would make it so much easier today if we were already comfortable writing statements and reasons, numbering them, doing our proofs that way. When you take your vocab test for chapter 2, a two-column proof is just simply where you list the steps of the proof on the left and you write the matching reason on the right. Okay, so your statements are on the left, your reasons are on the right, just like we've been doing. Two-column proof. Let's do one last fill-in-the-blank proof together and see how we do here, and then we'll stop, okay? So this one is a little different because there's blanks all over the place, right? I want you to write something great big on your paper right here. When you're doing your homework, you must write the whole proof, not just the blanks. You will miss points if you don't write the whole proof, and that may seem like I'm just trying to make you waste time. But the truth is you're not really going to be able to reason logically through the proof unless you're thinking about every statement and every reason. And when you go back to study and look back at your homework, it's going to make a whole lot more sense if you have every statement and reason listed, not just little pieces of it written on your paper, okay? So we're going to write the entire proof down, even if there's just a few blanks to fill in. Everybody clear? Write the whole proof every time, even if there's just a few blanks, for every assignment that we do. So we're going to try to fill this in. I'm going to come over to the board, and we're going to stop when we're done with this one. So let's see how we do. What's the first thing we're going to look for? The given, okay? So if I'm doing this on my homework, I'm rewriting my entire proof, statements, reasons. Number one, given. Number one, I've got to come up with the given. So here's what I would do, because we don't know whether or not they're going to list all of the given in number one, or that maybe there's given someplace else. So look and see, do you see given anywhere else as a reason? No, but there's one that's blank. Which reason is blank? 5. So look over at 5 statement. Is 5 statement part of our given? Does it say measure angle 1 equals measure angle 3 anywhere up here? No, not in the given. So that means the reason for number 5 is not given, and that means that there's not any other given listed in our proof. It's all in step 1, right? So that means we are going to put everything they gave us at the beginning as our statement for number 1. If you don't have room to cram it in right there, you might write 1A over to the side on your notes and write it out. So number 1, we're going to say angle 1 and angle 2 are supplementary. Bless you. And you are writing it word for word of what's in your given. Don't change it at all. And then they tell you angle 2 and angle 3 are supplementary. Thank you. All right. Number 2 they give you, but we're going to write it down and make sure we understand how they got it, because we're trying to learn through this fill in the blank process. So number 2, they said, if I know this, then that means the measure of angle 1 plus the measure of angle 2 is 180. And if I know this, the measure of angle 2 plus the measure of angle 3 is 180. How did they know that? What was the definition, theorem, postular property that told them that if they're supplementary, they add to be 180? Definition of, and it's right here, definition of supplementary angles. Definition of supplementary. And I know you don't have to fill that in because it's already there, but it helps if you go through and reason along with them. What did they do? Why did they do it? Okay, the next thing you have to figure out. They say it is SUBST. What does that stand for? Substitution. We're not abbreviating. That's one of the reasons why, because sometimes it's a little confusing about what they mean. But I'm going to tell you that they're actually wrong there. So we're going to cross this out. This is actually transitive. Transitive property of equality. So fix that on your chart. Transitive property of equality. Okay, we have to come up with what the next statement is using the transitive property. So look at what you have right here. You want to use transitive. What does transitive look for? What are we looking for when we're using transitive? We need 3 equations. Right now we have 2, and we're trying to come up with the third. So remember, transitive says if A equals B, B equals C, then A equals C. So what are we looking for in each equation? The same things, the part they have in common, so that we can get rid of it. What is identical on one side of our equation that is also identical on one side of the equation in the other one here? Careful, measure of angle 2 is just a piece. of this side, and it's just a piece of this side. With transitive, the entire side of the equation has to be the same as the entire side of the equation. They're both 180. They're both 180. So this is the part that's going to go away. This is the part that's going to go away. So if A equals B and B equals C, then A equals C. So what is our equation we're going to write down? The entire A needs to be written down and the entire C needs to be written down equal to each other. So what is our entire A? Perfect. Measure of angle 1 plus 2 now equals measure of angle 2 plus 3. So find what they have in common, get rid of that, but it has to be the entire side of the equation, and then set the left side equal now to the other left side. Okay, so that's number 3. Number 4, I'm going to tell you that I would never make you do in a proof. They're just saying angle 2 equals angle 2 by the reflexive property. The reason they're saying that is because they're going to use that fact that the angle 2 on the left is the same as the angle 2 on the right. But if you want to, you can scratch that out because I wouldn't make you do that. Okay? No. Nothing that I give you is going to make you do that. All right, so what we want to do is figure out how did they get from number 3 to number 5? That the measure of angle 1 is now equal to the measure of angle 3. How did we get from 3 to 5? Who said that? Dylan. They subtracted what? The measure of angle 2. Does everybody see that we have angle 2 on the left and angle 2 on the right? They just subtracted it away. The measure of angle 2 on the left is the same as the measure of angle 2 on the right. So what is my reason for number 5? Subtraction property of equality. Good. All right, this next one we are going to use all of the time, over and over and over again. Number 6. What does it say the reason is for number 6? Definition of congruent angles. You can just say definition of congruent if you want, but it's fine to include the angles since we're talking about angles. But we will use definition of congruence all the time. There is not a definition of equality. Definition of congruence. Definition of congruence says what? What's it mean to be congruent? To be equal. So if they tell you they're congruent, you can say they are now, if they're congruent, they are now what? Equal. And if they tell you they're equal, you can say they are now congruent. It goes both directions. It's biconditional. So your reason for your statement for number 6, you guys will still 5 minutes. Stay with me. Your statement, Jackson, get your stuff back out. Stay with me. Your statement for number 6 should never be a guess. The last statement in your proof is always going to be exactly what they told you to prove. You should never have to guess what the statement is. The statement is always going to be whatever they tell you to prove. So we're going from equals to congruence. Angle 1 is congruent to angle 3. If they're equal, then they're congruent. No little m's when you're saying congruent, little m's when you're saying equal. Okay, here's the deal.